Wow. Okay. Now we want to. I want to quickly say welcome to my YouTube channel. I remain my humble self, Tutor Yomi. Tutor what? Yummy? Your science tutor. Okay, if you're just coming to this YouTube channel, kindly subscribe to my channel. Why you have to do that is so as to enjoy whenever I upload new videos, and you try as much as possible to click on the notification button. And I'd like you to do me a favor. A favor is this: you could also share this video if it has blessed you. You could share it with your friends, you could share it with your classmates, share it with your neighbor children or your neighbors and all of that. Thank you very much for your compliance. Okay, if you've been following up, if you've checked some of my videos, you will see that I taught some things on that has to do with alkanes, organic chemistry. And so I'm not going to be dwelling much on this, but rather I will center more on Alkanes. But then it's important we recap little things or some things we have learned before, and then probably bring in some things. Now, students, we know quite well that um, having residual knowledge is what differentiates the scholars from the rest. Residual knowledge, what does that mean? You have read, you have studied, and then you are no longer with your book, and then you are not able to talk without opening anything, without looking anywhere, and all of that. That's what differentiates the the students who are doing extremely well from the average students. Residual knowledge. Okay, what do you know about alkane? Just let's quickly summarize. We have done it in the past. We know that alkanes are also known as paraffins. Yes. Number two, we know that they are saturated. Number three, we know that they basically alkanes undergo three chemical reaction. Your textbook Ababi will say two. Most of your level textbooks will just tell you just two. What are those two? Combustion and secondly substitution. For those in the higher institution, you could add this to your knowledge, and that is nitration. So aside alkane undergoing combustion and substitution, they also undergo nitration. So for the combustion reaction, so we know that methane, for example, react with oxygen to form CO2 and to form water, and then you balance the equation. For the substitution reaction, you have your methane reacting with chlorine molecule to form monochloromethane, and then you have your HCl, and then you have your monochloromethane reacting with HCl to form dichloromethane and HCl again, and then you have your dichloromethane reacting with HCl to form tetrachloromethane plus HCl, and then you have your tetrachloromethane reacting with chlorine molecule to form tetrachloromethane plus HCl, and your UV is the catalyst. Your UV. In the higher institution, a reaction like this, we say in chemical engineering, the reaction undergo three stages: initiation, propagation, and termination. Okay, so those are the three basic stages: initiation, propagation, and it is initiated by what we call the free radicals. Okay, so you see something like dot dot in the higher institution. Excuse me. Okay, so this is a substitution reaction. And then thirdly, I told you it undergo nitration. The nitration, you have C2H6, that's ethane, reacting with HNO3. This okay, maybe I need to wipe the Alkanes for now. Let me wipe the Alkanes for now. Okay, so you have something like this, C2H6 reacting with HNO3. Excuse me, to give you C2H5NO2 plus water. This compound here is called nitroethane. So this is ethane, an alkane member reacting with this acid, 2005, to give you nitroethane, and then you have water. So that's some basic thing. Alkane, basically they are used for fuel, either domestically and industrially and others. Okay, and of course their physical properties. Some of the members are colorless. Excuse me. Some of the members are colorless, and then like methane is colorless, tasteless, and is basically a natural gas. Okay. Not only that, methane as a member of alkane is less dense than air. Not only that, it has no action on litmus. Not only that, is slightly soluble in water. Actually, the solubility of the member decreases as the number of carbon increases. I'm sure you know that. I'm sure you understand that. Okay. So that's all you need to know about the alkane. And in case you want to know the general formula for balancing combustion reaction, you could just take note of this. You could take note of this, Y/4 excuse me. So this is it. This can help you to balance all combustion reaction of hydrocarbon, or combustion reaction of hydrocarbon. That's the formula you can use to balance. So take note, please. Then coming to alkenes, the alkenes basically are known as olefins. Please, you have to forgive me for my incessant sneezing. Just my health condition. Okay, just have a little catarrh. Now, so you have alkenes, and they are known as olefins. The first member is C2. That's ethene, and it's actually almost the most important member of the group, ethene. So it's like a king when it comes to petrochemical materials. It's more or less like a king. Okay, so unlike alkenes are unsaturated. Alkenes are unsaturated. As such, certain reactions alkenes do not undergo, alkenes undergo. For example, alkenes here have a general formula. That's alkenes desaturated. This is their general formula. But alkenes here, their general formula is this. N begins from 2 in this scale, but why here N begins from 1? But here N begins from 2. That's why the first member is 18. There's nothing like methane here, it's 18, double bond. Actually, for those on campus, they will tell you that this first bond is known as your pi bond. And this down one is known as your sigma bond. And your pi bonds are weak covalent bonds which are formed by lateral overlapping of p orbital. They are very weak. So your sigma bond are strong covalent bonds. They are not as weak as a pi bond. So this is why alkene are more reactive than alkane. The presence of the pi bond makes them reactive. Okay, now come back again to what we're saying. So there are reactions that alkenes undergo, the alkenes do not undergo, simply because alkenes are unsaturated. For example, addition reaction of alkenes. So you have something like this. Nickel, and then you have this, or you could have it like this. And then you have this. So you could have it. This is called hydrogenation. This is hydrogenation. And this is called halogenation. Halogenation in the sense that halogen member chlorine is added. Hydrogenation, hydrogen is added. Okay, so that's what you have there. So this addition reaction, alkenes cannot undergo because they are saturated. Okay, so this one way of preparing alkenes, you can say it by adding hydrogen to the unsaturated hydrocarbon. You can see it there. Okay, so alkenes undergo combustion, they undergo addition. Not only that, decolorizes bromine water. Bromine water, what we mean by bromine water is this. It decolorizes KMnO4. That's the purple color. So these are two compounds that are used for testing unsaturated hydrocarbon at O level. Okay, these two compounds, they are used for testing unsaturated hydrocarbon. Okay, so alkane does not react with these two, but alkenes react with bromine water and it reacts with KMnO4. Okay, so decolorizes this, decolorizes the purple color of KMnO4. So that's it. Not only that, even alkene undergo polymerization. Yes, alkene undergo polymerization. It reacts with H2SO4. Okay, and even a member of alkene, that's 18, will react with oxygen to form a compound. Look at the compound here. This compound, the name is called epoxy ethane. This reaction occurs at about 250 degrees Celsius, and the catalyst is silver catalyst that is used. So when ethane reacts with air, plentiful air or oxygen at a temperature of about 250 and in the presence of silver catalyst, that's a compound that is formed, epoxy ethane, from ether, from alkoxyhaloalkane. Okay, so that's where it's coming from. And you could see that alkane does not have plenty reaction unlike alkene, and it is because alkene is unsaturated. So you understand that. Okay, now if we look at the physical properties of ethane, for example, as a member of alkane, we know that it's not like methane that is colorless, tasteless, and all that. No, this one has a faintly sweet smell. I mean, ethane has a faintly sweet smell, and it's sparingly soluble in water. Of course, it does not have action on litmus, just like methane does not have action on litmus too. Okay, so let's look at the last one here, which is alkynes. Alkynes. Okay, alkynes have a general formula of this, where n begins from 2, 3. So if you put 2 here now, you put 2 times 2 minus 2, so you have C2H2, and that's the first member. The first member is known as ethyne. Ethyne is the first member, and this is the structure. Linear. It's linear in shape. The first member of alkane is tetrahedral in shape. The first member of this one is trigonal planar in shape, while the first member of this is linear in shape. Benzene is trigonal planar, alkane is tetrahedral, and why this? So for methane, let me quickly take you back. The bond angle of this is say this. For ethene, the bond angle is 120, and for ethyne, the bond angle is 180. So this is trigonal planar, this is tetrahedral, and this is linear. Please take note. Tetrahedral, trigonal planar, and this is called linear. So it's linear. So alkyne rather has 2 pi bonds, and look at the sigma bond down. The first 2 here are called the pi bonds, and why the down here is called sigma bonds. But in alkane, you will see that the pi bond is just 1, but in alkyne, the pi bonds are 2. Please, this is what makes this to be more reactive than alkane, because there are pi bonds. There are pi bonds, and these pi bonds are so weak. They are weak covalent bonds. For the sake of those in the higher institution, let me just show you something very quickly. Look at this reaction I just showed you. Look at it. This is for those in the higher institution, please. This is not for our secondary school friends. Because you may not grasp what I'm going to say now. You may not accept if you are the smart type. Okay, now looking at what we have here now, this is pi bond. This man is called an electrophile. Electrophile, what are electrophile? Electrophile are reagents which are deficient in electron, or electrophile can be a reagent that attack electron receptor, while nucleophile electrophile are also known as electron loving. And why this nucleophile, ethene is a nucleophile, okay, electron 18 or nucleus loving. Okay, so is rich in electron, this is deficient in electron. So this, what is the mechanism of this reaction now? You see this electrophile coming is deficient of electron, so it will come here and break this pi bond, because pi bonds are very weak. So it will break this pi bond. This pi bond is susceptible to attack, and when it's broken, all you have left is just sigma bond. Excuse me. All you have left is sigma bond. So that's what we are saying. So from this ethene now, you now have ethane, because the attack was carried out by an electrophile who is deficient of electrons. So please take note of that. Okay. I'm sure that's very clear. Okay, without wasting much time, alkenes, terminal alkynes are more reactive than others. What we mean by that, because if I don't explain that, some may not grasp. This is what we mean by terminal alkyne. So look at something like this now. This is going to be more reactive. you can see as soon as you mention the alpha carbon, you are having the functional group. The functional group is here. But here, the functional group is at the center. This is close. This is terminal. This is not terminal. This you have to mention alpha and beta before you get to the functional group. But here you have to mention just the alpha and you get to the terminal. And so this is more reactive than this. So terminal alkynes are more reactive than others. Take note. Okay. Now, it should be noted that virtually all the reaction, that's why I don't want to waste time. I didn't tell you how this is prepared, and how this is prepared. Let me do that in a moment. How do you prepare alkanes in the laboratory? I told you one, that using unsaturated hydrocarbon, that is ethene, reacting with it, that's alkane. So you can prepare it like that. Number two, you could react sodium that is organic salt plus soda lime, organic salt plus soda lime, and then this will give you so look at this another way. So this is sodium ethanoate. It's an organic salt reacting with caustic soda, and then to give you sodium triisocarbonate 4, and then this is methane. And this methane happen to be a member of alkane. So this one another way of preparing alkane in the laboratory. Okay. So you can see the reason why soda lime is used in the reaction, that is not deliquescent and it does not readily attack glass. For the WAEC or whatever exam you prepare, for those in SS3 now, the reason soda lime is used, okay, the reason why they mention soda lime is because soda lime is comprised of slake lime and caustic soda. Okay, so it's because it's not deliquescent and does not readily attack glass. Take note. So this is another reaction that this is another way of preparing alkane. But let's see how do you prepare this man in the laboratory. The dehydration of ethanol with H2SO4. So this is the reaction. The reaction undergo 2 stages. This is the product that will be formed, and the compound is an unstable compound, ethyl hydrogen tetraoxosulfate 6. So the ethyl hydrogen tetraoxosulfate 6 decomposes to regenerate H2SO4, and then you find ethene being given out. So you can see now that's as alkane is prepared. So you find this man here, H2SO4 is a special acid that acts as a dehydrating and hydrating agent. It acts as what? Hydrating, student, listen, and dehydrating agent. This H2SO4 you're seeing. So conc H2SO4, you're reacting with ethanol, it will give you ethyl. It will give you ethyl hydrogen tetraoxosulfate 6 and water. And at the end of the day, what is observed? This water is gone. That's why it's called dehydration of ethanol. Dehydration means removal of water. So the water is removed and permanently removed, and ethene is prepared. So that's one way of preparing ethene. You can see preparing ethene in the laboratory. Let's come to this quickly. To prepare alkyne, how do you do that? Quickly. So you can react, what do you call it now? Calcium carbide with cold water. Calcium carbide with cold water with steam, and so you have C2H2. So here you have Ca, and then you have this. So the reaction is, I think, is balanced. Okay, not balanced. You have to. So you have 2 oxygen and all that. So this is calcium carbide water, and then calcium hydroxide.